Hey everyone, welcome back. Today is day 3 of my 30-day FAANG grind, and I'm solving 6 to 10 LeetCode problems daily, breaking each down on video and sharing with all of you on YouTube. I'm Divya, by the way. I've interned at Massachusetts Institute of Technology, where my area of focus was on statistics and machine learning, and currently I am at top 0.3% globally on LeetCode. Unlike most of you, I am also preparing for FAANG interviews. Yesterday, we tackled two pointer techniques, and today we are jumping into prefix and suffix based problems, which are super common in arrays and strings, and a favorite theme in FAANG interviews. We will also sneak in a few sliding window refreshers to keep all those patterns sharp. But before we begin, if this video helps you, please give it a like, share with someone who is preparing, and please hit that subscribe button so we can crack these interviews side by side. Let us go. So today we will be tackling two different problems, 930 and 1248. They are pretty identical problem. I will start with 930 and then we'll see it resembles exactly with a very minor tweak for 1248. Okay. So 930 states binary subarrays with sum. It states that we have been given an array where the values are binary numbers 0 and 1, and we have to return the count of subarrays such that the entire sum of the subarray sums to the goal, okay? That has been given in the example and the problem statement as well. Let us go to the dashboard and we'll try to investigate and find an optimal solution. But before we do that, we'll also take a look at brute force approach, okay? So we have been given the nums array and the goal, and the objective is to return the count of subarray such that it sums to goal, okay? How will we approach it in a brute force manner? Okay, it is pretty clear and should be evident. The brute force approach requires that we generate all the subarrays, and for each and every subarrays, we compute the sum and find a match for all those sums that equates with goal, okay? And then make a count variable and keep on increasing it and return at the end. We have printed every single subarray, okay? But that path will take order of quadratic, something that we need to avoid because it is something not very efficient. So what will be the efficient part? So the efficient part is pretty identical to 560 that we did on LeetCode just before this problem, okay? And over there, I told you that the entire crux of this problem depends on this diagram, this specific diagram, okay? The entire solution, I assure you, will revolve around this diagram. So I will go on, on this diagram, the explanation of this diagram once again, just to, make things pretty clear, okay? So what is going on here? So this box, it represents the entire sum of the array, starting from the 0th index till the last index. Okay, you can think of as the prefix sum, but I will consider or I will call it a current sum. Okay, name does not matter in this case specifically because you can change the name interchangeably. Okay, I will be sticking with current sum, which is the entire sum from 0 till the last index. Right? What is this blue part? This blue part is the goal, the magnitude of the goal part. Okay, and what is the screen part? The screen part is just the difference that remains after chopping out these two things, okay? The entire sum minus the goal part, then this remaining difference will be remained, okay? Let us look at this mathematical equation, just a very simple one. We have current sum minus goal equals to B. What does this mean? Illustratively, it means, hey, if this is my current sum, and from this current sum, if I just chop out goal, what will I remain with? I will just be left with the green part, right? And the green part is B, correct? This green part is something that we'll call as remaining part, okay? In other words, if I just take a look at this diagram, this equation, and try to, draw an illustration of it out of it, what does it mean? It means, hey, if this is my current sum, and from this current sum, if I just chop out B, what will I remain with? If I just chop out B from the entire current sum, what will I remain with? I will be remaining with just this blue part, which is the goal, correct? All right. So once that is clear, let us move to the next step. And before we move to the next step, let us keep two things in mind. The first thing is that we will be requiring a dictionary where we'll keep a count of the current sum or the prefix sum up till the current state we are in, okay? As it states, as is stated over here, the first thing that we'll do is we'll capture the current sum in dictionary if it is not already present. If it is present, then we simply increase the frequency or the count of the current sum, okay? And second thing is that we'll take the difference. Which difference? This difference we're talking about, right? Primarily this difference, okay? So let us start. Initially, my pointer will point to this thing, current sum is 0. it will increase by 1, okay? And once it has increased by 1, let me just drag it down a bit, all right? Okay. So once current sum has increased by 1, let us put it in this equation. Current sum is 1, goal is 2. What do we get? We get -1. We ask, hey, is -1 present in this dictionary? The answer is no. So what do? We see that our current sum, the current prefix sum at the current state is 1. What do? We add that in dictionary. Why? Because it is not present. Okay, good. Our pointer increases, it comes to 0. The current sum, it remains unaffected. We just write this equation once again. 1 minus 2, it becomes -1. Hey, is -1 present in dictionary? The answer is no. What is the current prefix sum? 1. Is it present? Yes, it is present. What is its frequency? 1. Please increase by 1, make it 2. Good. We come over here and this value is 1. So our current sum, it will increase to 2. We come over here, add this equation once again. 2 minus 2, it becomes 0. We ask, hey, is 0 present in this dictionary? Remember one thing, when I declare this dictionary, I already declared a predefined state, this one, right? Why did I do that? I did that because this was the edge case that I needed to avoid. Please watch the previous video, 560. I have explained in great detail why this is important and where is it coming from, okay? So for now, in this video, I'll just assume that you know why it is declared and what is the importance of this thing. So 2 minus 2 is 0. I ask, hey, is 0 present? The answer is yes, it is present, and its value is 1. I will increase the value of result by 1. I will ask, hey, is 2 present in the dictionary? The answer is no. So I will come over here and I will put in 2 and declare its value to be 1, okay? My pointer moves 1 ahead, it comes to 0, current sum remains unaffected. I run this once again, 2 minus 2 is 0. Hey, is 0 present? Yes, it is present, the value is 1. Let me increase the value of result by 1 and it becomes 2. And now finally, I'm at the last point, current sum increases to 3. I come over here, 3 minus 2, it becomes 1. Hey, is 1 present? Yes, it is present, but what is the value of 1? Frequency of 1, it is 2. So please let us increase the result value by 2 and it becomes 4. Is 3 present? No, it is not. Please add 3, the current sum or the prefix sum, which is, and its value will be 1. And we come out of the array and we stop and we return the result, which is 4. Is 4 the right answer? Let us see. See the subarray. Our goal is to capture the window or the subarray so that it sums to 2. This is the first window. The answer must be 4, right? This is the second window. This is the third window. And this is the fourth window. As you can see, there is no other window that is possible for this specific case, okay? As far as the code is concerned, it is pretty identical to 560. So instead of writing the code or explaining that, I will just move to the LeetCode dashboard and I will try to submit a solution over there. As far as time complexity is concerned, since we're iterating through the entire array over here, so it is order of n time complexity, linear bounded. And since we're also declaring a dictionary, so our space complexity is also bounded linearly, okay? Let us go back to LeetCode and we'll try to submit the solution and see how it goes. I've already written the code for this and I will just copy and paste my solution, which looks like this. It is pretty identical to 560. So without wasting any time, I will just submit it. And as you can see, this has been submitted and the solutions has been accepted. And if I come to this second problem, which is 1248, it is also extremely pretty identical to binary subarrays with sum. This problem, okay? In this problem, in 1248, what we just need to do is you can go through the problem and switch every even number to 0 and make every odd number 1, okay? Which is done in line number 7 over here, okay? And every single thing, it remains perfectly fine, exactly copy pasted, okay? And if you don't believe me, I will just run it and show you that it goes perfectly well. And as you can see, it has been accepted, okay? And the test cases have been passed and submitted. So yeah, that was all for this video. I will reiterate once again, 560, 1248, and 930. These three problems are extremely identical and they revolve around this diagram. This diagram is really important and it is like the crux of this problem. So once you understood this diagram, you can then move to the theoretical aspect of this problem where you try to write down the code. But getting a visualization is extremely important. I will always emphasize, to get that first. So yeah, that was all there was to this problem. We tackled two problems today of same types, three problems in fact. If you have any doubts, please leave it in a comment, ask me, okay? And yeah, I will see you in the next video. Bye bye.